Thank you for the introduction, and yeah, I agree, our products are very good. Yeah, the title is a little bit long. I'll tell you about what it is behind. I'm with Nanoscribe since more than 6 years now. I'm since several tens of years in the photonics community. A little bit about Nanoscribe first, for those who don't know us, because I think it's the first time that we are at this conference and in this community really presenting things. So we are a spin-off from the KIT, not from another company, like Skill, a long time ago, and we are 100 people right now. We have locations in Karlsruhe, where we are located, so in a suburb of Karlsruhe, it's a KIT basically. We have a subsidiary in Shanghai and in Boston, so we serve our customers worldwide. And since December last year, we are part of the Lab 14 group, so some of you may know them. There's Heidelberg Instrument is part of them. That's quite beneficial for us for the future also. But now coming back to the subject, so to my understanding, and I hope I got it right in the last 2 days, we are lenses on top of the LEDs most of the time, and also several beam shaping optics in the beam path. So the lenses, micro-LED arrays should reduce the Lambertian emission, and so the MLA can help to have a more directive emission. And the beam combiners can be at different places. I actually don't know wherever they can be. But so it's prisms, microlenses. I've seen plenty of things in the different presentations here and in the in talks with customers before. And we can do this and in freeform. So the question is, why don't print them where they are needed instead of do an active assembly or things like this? So most of the time, one blocker was that you needed a transparent resin in the UV. We have this now since the beginning of the year. And optical surface quality is also required. This we can do since actually 6 years, but now it also can be done in 3D and with a transparent resin, and I'll talk a little bit more about that. So the background of our technology, it's a 3D printing technology, but close to lithography. It's called 2-photon grayscale lithography. Very quickly, we use a femtosecond oscillator laser, galvo mirrors, microscope objective. We dip into a resin, so it's like when you do high-resolution microscopy, you have a adapted resin, and then we move the beam inside the substrate. And the nice thing or the new thing is basically we patented is we can tune the voxel. So we don't need to do a lot of fine layers to have an optical surface and an optical quality. We can tune directly the voxel in a thicker layer, which is already a huge speed enhancement. How does it look like? A scheme a little bit. So that's the principle, how it works. And this is what it looks like. So we did a comparison. We took the Benchy boat, as 3D printers do all the time. We have all different other images at the booth. I can show you what is the difference. So you see, this is basically, we took 4-minute print time as a target. You see the size, what we can print. If you want to do with classical slicing, hatching, also fine slicing or matching the speed, you need to go actually to coarse slicing in this case. And with the grayscale lithography, we managed to have speed and quality. So it's at least 10 times faster. That's a relative value. I'll give you some times afterwards in the presentation what this means. This is another quite impressive, at least from my point of view, print. So it's done together with our customer Print-Optics. They did the design. So that's an example lens for endoscopes, but it shows really nicely what is possible in freeform optics. So we printed this in one go. This at the moment is a 1-hour print time. I know Print-Optics can do this faster. They have developed their own processes with our systems. So you have optical quality at any optical surface. This is for imaging. It's not for beam steering. That means also the bulk material has the right quality. We can also do this at wafer scale, not 300 millimeter. I'm sorry for that. We have high resolution. We can do the optical surface quality. As I said, we have the transparent resins. We can do it in full 3D. And additionally, that might be required for prototypes for this community. We can